Hey guys, Mr. Decker here. This is Unit 3, Lesson 25, the game design process. All right, let's take a look at our essential question. It is, how does having a plan help to make a large project easier? Well, it makes it easier. It's a big time saver. If you've already got a plan, the guesswork is already finished for you, right? If you have a plan for a big project, that means that you don't have to brainstorm in the process. You can just go ahead and do what you've already told yourself to do. And having that plan makes sure that all of your objectives are met and that you haven't forgotten anything, left anything out, so on and so forth. So it makes sure that nothing falls through the cracks. All the details are there. All right, so don't forget to answer that question by hitting that blue submit button, answering it with 2 to 3 sentences. You can do that now, honestly, or you can do that later. So let's jump into the lesson. I've already got it pulled up to bubble 1 on the assignment page. The first thing I want to do here is pull up this project guide. So your screen will look very similar to mine in this instance. So go ahead, under resources, click where it says Defender Game Google Doc. Click the Google Doc. It'll open up here, click make a copy. And then we already have this filled out game plan for the game we're going to be making over the course of this lesson. We've got the game description. You're an alien defending your cake from evil ladybugs, right? And so on and so forth. We've sketched the game. We have our sprites, where they start, what they do as they're updated throughout the game. We have our variables, which is just a score. And the functions that we're going to be establishing. So go ahead and have this open. We're going to be going back to it periodically through this lesson. As we work our way through the bubbles, it's going to ask you to come back to this and look at it again and again to make sure you're following it. And I might just be asking you to complete one of these yourselves for our final project for this unit. So make sure you familiarize yourself with this so you're ready to fill one out on your own for our last assignment or our last big project. So bubble 2. Defend your cake. This is an example of a defender game that you'll build by the end of this lesson. To defend your cake, move the alien with arrow keys to block the ladybugs and push them into the water. All right. So let's play the game. So I'm the alien sprite, and I need to push the ladybugs off the bridge and into the water before they can get to the cake. All right, so far, not bad. Working. So every time I push a ladybug into the water off this bridge, sayonara ladybug, my score goes up by 1. It looks like ladybugs stop coming out or coming down the bridge, so it resets them every time I push them off, and my score goes up. So there's probably a function handling that, or an if statement. And so far it doesn't look like anything ultimately happens. I just keep going. My score keeps going up. And I'm pretty much a boss at this game. Let's start letting some ladybugs get to the cake. Oh, the score goes down rapidly. Let's see. Looks like it goes down by 4 every time a ladybug gets to it. Or 5. Does it go down by 5 every time? Yeah, it does. Wow. Okay. So let's see. If you were making this program, what sprites would you need? Well, we need a sprite for the cake, the alien sprite, and the ladybug sprite. What variables would I need? Just the score variable. What functions would you use? I'd probably have, let's see, a function for resetting or a function for movement for my alien sprite, a function for resetting my ladybug, so the enemy sprites, resetting it when they are pushed into the water, and resetting them when they touch the cake. Let's see. What else might I have a function for? Anyway, let's proceed. Bubble 3. All right, plan your project. So this is where we're supposed to be looking at the project guide, which has already been filled out for us. Does this project guide describe the same sprites that you thought of? Let's see, where are the sprites? Sprites. Player, the alien, the cake sprite, and the ladybug sprites. So yes. Does it use the same variables to store information? We said we needed a score. Yes, that's our one variable. Are the functions that it describes the same functions that you described? Let's see, game background. Okay, yeah, I didn't think of drawing the background in a function, but yes, you would want that. Enemies touch cake, resetting there. Move the player. Yes, we thought of that. Displace the enemies. Yes, we thought of that. For touching the water. Yes, we didn't think of it about player pushing the ladybug, so we would probably use a displace block and then show score on the screen. That's another one we didn't think of. Okay, cool. All right. See how great planning is? There were things we didn't even think about just off the cuff. And let's see. Before we get started, you'll want some better animations for each of our sprites. So do this. In the animation tab are animations for each of your sprites. Go look at what they are. In your code, give each sprite its appropriate animation. Use the ones provided for now, but later you'll be able to go change them. So in animation, we've got our alien, our cake, and a ladybug. So for the cake, we need to go set animation, cake, and we're going to set it to the cake. And then set animation for the player, whoop. Set that animation to the alien walk right. On the alien, okay, it does have the, okay, cool. Okay. I'll be able to change them later, so I'll probably want an alien walk left. I just want to check something real quick. Let's go back to the game. If I'm moving him, okay, yeah, so he does face different directions, so that's something I will want to update. All right, let's see. And then both of those need to be the ladybug. Enemy 1 and enemy 2. So enemy 1 is going to be a ladybug. And enemy 2 is going to be a ladybug. So let's run that. Yeah, there they are, way up here in this corner, stuck. Okay, cool. That's bubble 4. Finish. Continue. Bubble 5. You'll need to get your enemy sprites to a random position and moving across the screen. Okay. Do this. After each enemy sprite is created, set its X position to 0. All right. I guess at the beginning of the game. So X, this is the enemy sprite. So that's going to be enemy 1 and enemy 2. So enemy 1, X position is going to be 0. And enemy 2 is going to be 0. And then set its Y position to be a random number between 150 and 250. Oh, whoops, Y position, not velocity. So let me Control C, Control V, make this a little faster. And we're setting this to a random number. So random number, and it's set between 150 and 250. So 150, tab, 250, 150, tab, 250. And when I said tab there, I just mean that I'm hitting the tab key to automatically move my cursor into the next spot where I can put my number. So this is taking some of the guesswork out for us. That's nice about what these numbers need to be. And then set its x velocity to 2. So back to sprites. Velocity x. Velocity x. And then this is should still have enemy 2 copied. Yep. C, Control V. And we're setting these to 2. So now my ladybugs are moving and they're getting random Y positions. That's good. Excellent. All right, test your program. Your enemy sprite should be now moving across the bridge, and they are. Finish. We're on bubble 6. Moving right along. Moving left and right. Now you'll just need to get your character moving left and right and changing its animations. Do this. Inside the move player function. Where's my move player function? Right here. Okay. Down on line 49. Use a conditional to detect when the right arrow is pressed. So control if world key down right. If it is, move the player sprite to the right by 3. So sprites, we're going to use the counter pattern in this case. Let's see. It's going to be sprite.x, player.x gets math. Moving him to the right, we're adding. And in here, player.x plus 3. Okay, so now run it. Now he moves to the right. Okay. Use another conditional to move him left. All right. So I'm going to Control C. And my cursor is blinking right there. Control V. I'm going to say key down left. If you couldn't figure out that Control C, Control V, you can build this back out again. I'm going to throw this out. Math. And actually, watch. I can say player.x minus 3. Enter. So now he moves both left and right. Okay, test your game. Your character sprite should now move left and right when you press the left and right arrows. It does. All right, and then notice that this function definition is called inside the draw loop. Here's move player right here. If it wasn't, it wouldn't work quite right. Okay, so did it want me to do up and down yet? I guess not. Finish. We're done with bubble 6. All right, bubble 7. You want your player to move up and down as well. True. Do this. Inside the move player function, use a conditional to detect when the up arrow is pressed. All right, so still back down here in the move player. And we're going to control if. And let's see. World, key down, up is already set. And then sprites, Y, player gets math. I'm going up, we are subtracting. Sprites, player.y, minus 3. And then control again, so we want to do a down. And world, key down, down, key down, down. And sprites, sprite.y, player.y, gets player.y plus 3. Enter. So let's make sure up, down, right, left. Everything's working. Okay, cool. All right, run it again. All right, okay. Test your code. Your character should now move in all 4 directions, and he does. Finish. Bubble 8. Change the player animations. You can change the animation when the player changes direction. Do this. Inside the animation tab, copy the animation of your player sprite. Animation. Here's my copy button. I just hit duplicate. And I'm going to make this say alien walk left. Making sure I maintain camel case. And then these guys, I'm going to flip vertically. So he's facing left, and I click the other one and flip it. Now they're both facing the correct direction. And while I'm at it, I'm going to make sure that my sprites are cropped properly. It looks like they are. Now, flip each frame of the new animation so that the sprite is facing the opposite direction. Did that. Rename your new animation. Did that. And inside the move player function, set the sprite's animation so that the sprite or so that the player changes the direction it's facing when the left and right arrows are pressed. So down here in move player right and left, we're going to go into sprites and set the animation for each one of these. Player and player. So when I hit left, I want him to be alien walk left. And when I hit right, I want him to be alien walk right. So let's test it. Awesome. It's working. All right, finish. And continue. Bubble 9. Touching the cake. If the enemies get all the way across to the cake, you should place them back at the left side of the screen to decrease the score. Okay. Oh, and decrease the score. I'm sorry, not to decrease the score. You'll to start, you'll write code for only one of your enemies. Okay. Do this. Inside the enemies touch cake function, right here, use a conditional to detect whether enemy 1 has touched the cake. So control if sprite is touching, detecting if enemy 1 is touching cake. If it has, loop the enemy back to the left side of the screen. Okay, so I need its X to be 0 again. All right. Set its Y position to be a random number. Okay. So we're kind of doing this code that we've already done up at the top. So math, random number, 150 to 250 again. And then use the counter pattern to decrease the score by 2. So variables, this score equals math, decrease the score by 2. Score minus 2. So here's our score variable as it's set up. And then here's us telling it to go down by 2 whenever an enemy touches the cake. So let's see. So enemy 1 resets. All right. One of your ladybugs should now reset when it gets to the cake, and the short score should go down by 2. So I guess I'm going to be doing this for enemy 2 on the next bubble. Second ladybug. All right, your first enemy sprite should be resetting when it gets to the cake. Now you'll want the other ladybug to reset as well. Do this. Inside the enemy's touch cake function, you should have written code that resets enemy 1. Copy the entire if statement you wrote with Control C, paste the code inside just below the last one with Control V, change the name of the sprite in that code from enemy 1 to enemy 2. Okay. So we're going to copy this if statement. We're going to highlight it. Control C. Notice my cursor is blinking right there. Control V. And now I'm just going to enemy 2 all over. And Control C, Control V, Control V. Now they should both be working. Keep starting them in the same kind of spot. There we go. Now we can test. All right, that's working. They're resetting when they touch the cake. My enemy's touch cake is called in the draw loop on line 26 right there. Without that, it would not be working. Okay, bubble 11, moving right along here. Creating functions. Your program now includes code in 2 places to set the enemies on the left side of the screen at a random Y location. You can create functions to reset each of your 2 enemies to remove repetitions from your program. This will make your program easier to read, allow you to change it more easily, and allow you to quickly reset your sprites at the other points in your program if you need to. Do this, okay? At the bottom of your program, create 2 new functions. All right. Let's see. Functions. And I want to separate these out. You see how there are these blocks? I'm going to show text. I'm going to put my cursor at the end of line 88. After that curly brace, enter. And after this curly brace, enter. Show blocks. And now I have these separator blocks. All right. At the bottom of your program, create 2 new functions. Set enemy 1. Notice camel case is used. Set enemy 2. Inside each of these functions, place the code that sets the enemies on the left side of the screen and gives them a random Y position. Sets the enemies on the left side of the screen and gives them a random Y position. Wherever the code for set enemy 1 and set enemy 2 appears in your program, replace them with a call to the functions that you just created. So are those already in the draw loop? No. Oh, I see what it's saying. Okay, so I grab all this. Control C. Well, here. I'll lasso it so it's highlighted. Grab it, and we'll put it down here into set enemy 1. And then we're going to go up here, lasso this, set enemy 2. And then inside these 2 if statements, we're going to call those. Set enemy 1, set enemy 2. Let's make sure those are working. Go to the gate. Go, 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 go. Awesome. It's working. All right. I have a feeling that's going to come in handy later. Let's finish. Continue. We're on bubble 12. displace the enemies. It's time to write code for some more sprite interactions. Your player sprite should displace the enemy sprites. Do this. For this level, you'll be writing code inside the displace enemies function. All right. Where is that? Displace enemies. There it is, line 71. Write code that makes the player displace both enemy sprites. Test your program to make sure your player is displacing enemies, but they keep moving right after the player moves away. Hint, you can use sprite.debug to see your sprite's colliders if you need to debug your program. Okay, sprites. Where's displace? There it is. So we just need 2 of these, and you don't need if statements for these. So sprite player displace enemy 1 and player displace enemy 2. And I think that should get it. Double checking enemy 1, enemy 2. Run. Yep. Okay. That's working. And make sure your players displace enemies, but they'll keep moving right after the player moves away. Yep. Okay, finish. Bubble 13. Touching the water. The last part of the game that you'll need to write is the code to reset the sprites when they touch the water. Luckily, you should have already written functions that reset each sprite, so you'll just need a good way to know when either sprite leaves the bridge. Start by writing the code for a single enemy, and then copy paste and make small changes to create code for your second enemy. All right, do this. There's a lot to do this time. Enemies touch water function. Where are you? There it is. Use an if statement. Control if to check whether enemy 1 is off the top of the bridge by checking whether its y value is below 140. Okay. Sprite dot math is below 140, so less than sprite.y. I'm doing this for enemy 1. It's less than or below 140. Within your if statement, use your enemy 1 function to reset the sprite. That's where that's going to come in handy. I gotcha. So set enemy 1. And then add 1 to the score. Okay. Variables. Math. So this is going to be score gets score plus 1. Okay. Use an if statement to check whether enemy 1 is off the bottom of the bridge. Okay. Control if math. This is going to be a greater than this time. Above 260. So sprite.y enemy 1 y greater than 260. It says, not 2560, but 260. Within your if statement, use your enemy 1 function to reset the sprite. Set enemy 1. And then we're going to, I'm assuming, make sure the score goes up. So let's see. Variables. Well, I'll tell you what. Let's Control C. Control V. There we go. Let's run it and make sure that's working. It's not working for him. It's working for this one. Oh, why is it going down? Hold up. Oh, I see. I see. I moved that and I shouldn't have. So this needs to be, where's that? If he's touching the kick. There we go. You stay there. And grab this one and move him up as well. That's my bad. So if you catch that, make sure you're paying attention and get that corrected. Yeah. Yep, that's working. Score is going up now. Okay, now let's copy and paste this code. So we're gonna Control C, Control V, and we're gonna change enemy where it says enemy 1 to enemy 2. Oh wait. Oh, okay. Oh, whoops. Control Z. I got mixed up. I gotta go down here and do this. No wonder I was looking at that like it was new information. Okay. Now this I'm changing to enemy 2, enemy 2, enemy 2, and you guessed it, enemy 2. Now let's test. All right, that's working. Let's let them run to the kick. Sweet. All right, my game's working, bros. All right. Finish. Continue. All right, some challenges. Let's knock these out. What's our time look like? Not bad at all. All right, choose from the following activities. We're going to do all of these activities, A through D. So high score background. Create a new background that shows up when players reach a good score of your choosing. Example, turn the background pink when the player gets over 10 points. Do this. When drawing the background, add an if-else statement to check if the score is above some number like 10. Put the normal background in the else branch. Draw a different background if the score is above that number. Okay. So where's the draw background? There's show score. Set enemies. Okay, here's the game background. So we're going to go into control, grab an if else, and we're checking to see if the score is greater than or equal to 10. And we're checking the score. All right, and then I'm going to have the normal background in else and the new background in the then part. Okay, I guess I need all of it. Okay. I guess I can just grab it and put it in here. And then not fill pink, put background color. Let's see if that works. Gotta get a score of 10 first. Pushing them back is a strategy. Oh, okay, so the whole thing turns pink, so I need the rest of this code as well. Control C. Put my cursor there, Control V. And I'm going to, let's run it. Gotta test again, make sure. Okay, cool. Now it's working. Now it's working. Okay. All right, we did that one. Da-da-da. And let's do B, randomize enemy speed. Use random numbers to make some enemies move faster or slower. Do this. Create two variables to store the speed of enemy 1 and enemy 2. All right. So variable and variable. Whoop. We've got to name them. So this is going to be enemy 1 speed, enemy 2 speed. Okay, set the velocity of the two enemies using the two speed variables. When you create each enemy, generate a random speed. Okay, set the velocity of the two enemies using the two speed variables. I will be right back. All right, back to it. So I started out, I got confused because I was setting this up slightly incorrectly. I don't want to set their speed at the beginning. I'm going to just establish a variable. So we're just going to declare the variable. Give it a name. So we're going to have variable enemy speed 1 or enemy 1 speed and enemy 2 speed. All right, that's established. Now it gets a little confusing, so follow along closely. The reason why these are here is because they have not been called. They're declared, not called. So we need to go down to set enemy 1 and set enemy 2. And set enemy 1, we've got it resetting its x value, resetting to 0, putting it back over here, and then its y, a random number between 150 and 250, which gives it that random placement on the bridge. Okay. Now, every time it resets, let's see, we want x equals, so this is going to be enemy 1 speed gets a random number. Let's just say between 1 and 5 because 10 is really fast. And then we're going to have to lock its velocity to this because we haven't actually told it how fast to randomize the speed yet. So velocity x, enemy 1 velocity x gets enemy 1 speed. Now we're tying that variable to this random number. So this, it's locking that value in each time it resets. So now we need to do the same thing for enemy 2. So back in my variables drawer, enemy 2 speed, and math, random number between 1 and 5. And then back to sprites, velocity x, enemy 2, and we're matching it to enemy 2 speed. So now we should get random speeds as they reset. Woo! Oh yeah, that adds a challenge for sure. Oh man, I missed him. See what I mean about 5 being really fast? Okay. Holy moly. No! Okay. All right, I'm going to say 5 is too fast. I want my game to be playable. So 1 and 3. Game testing is important. Walk him back. Get him up there. Now I've got time. Now my game is playable. Let's make sure my pink is still working. One more. Good. All right, cool. Okay. Whew. All right, that's that one. That was a challenge. Okay, now change the visuals. Change the visuals of the game so that your player, enemies, or cake look different. All right. Change the visuals of the game so that your player, enemies, or cake look different. Change the player's sprite. Okay, so now we get to be a little bit more creative, I guess. And I'm going to leave this one up to you. If you want to change what these are, what your animations are, by all means do so. Just be aware that like if I add a new sprite, if it doesn't already have a couple different images to create an animation, like that walk that the alien does, or the kind of wiggle that the ladybugs do, then you're gonna have a bad time. So make sure that whatever you change it to, where are the aliens? Fantasy, maybe. Yeah, okay. So make sure that you've got like this, you can see if it actually has multiple frames to it for an actual animation. So if you hover over it and you don't see any movement, that means that it doesn't have more than one frame. And if it doesn't have more than one frame, it's not going to move around and give you that cool effect of movement, right? So be aware of that. I'm not going to change mine, but you can certainly change yours. So be creative as you want to be creative. All right. Now, in the game, D. End the game when 3 enemies get to the cake and print the score. Do this. Create a variable that keeps track of how many enemies have gotten to the cake. Okay. Use a conditional to check whether an enemy has gotten to the cake. If it has, increase your variable. Okay. So we'll start it out at 0. Variable. What do I want to call this one? If they get to the cake. So we'll say munch. Because the bugs are munching on the cake. Let's see. Use conditional to check whether enemy has gotten to the cake. We'll set it to 0 at the beginning. Checking whether an enemy has gotten to the cake. So enemies touch cake. We're going to work inside this function again. If it has, increase your variable. So we're going to... Did I use the right? Yeah, okay, I declared it. Variable munch equals 0. Enemies touch cake. Need to put one of these in each one. If then munch gets and munch gets math. munch plus 1, and munch plus 1. All right. Use a conditional to check whether the value of your variable has reached 3. If it has, cover the game with an end screen that displays the final score. So that I'm going to put into my draw background. Where is it? Where is it? There. Game background. Okay. So let's see. If math greater than or equal to, where are you? There you are. If munch is greater than or equal to 3. Oh, whoops. I don't think I need an if-else statement. Then cover the game with an end screen that displays the final score. So let's draw our end screen. So background, black. We'll say game over. So text. And we'll say fill color green. And text size. $30. Well, let's try 40. Game over. And I want that to be, let's just run it and see if it works first. Get him out of the way. We're just testing. Okay, game over is way up there. So we want game over to be in the middle. All right, I'm also going to show you a couple more things on this one that I think you'll be interested in, because a game over screen is important. So we're going to also set visibility and freeze our sprites and all kinds of stuff here so that our score remains stagnant. Game over, I want to be at like, let's see, so at 100x. And 200y, run it. Let's test that, see where that ends up. Okay, let's do like 75x. And then we're going to freeze the game. So sprites. Visibility. We'll do visibility first. Player. E1. And E2. And the cake as well. We also want to freeze all of them. So the cake doesn't move, but enemy 1 and enemy 2, we want to set their velocity to 0. They don't move, and it doesn't impact the score anymore. So let's see, run. But the score disappeared. What happened? Oh, enemy won. Run. Get him out of the way. And I really want my score to remain up there. There. Good. Awesome. Sweet. Use a conditional to check whether the value of your variable has reached 3. If it has, cover the game with an end screen that displays the final score. Okay, perfect. All right, so we did it. And we did it in 143 lines of code. Not too bad. So we'll finish right there. Continue. And that's it, guys. I hope you enjoyed this lesson as much as I did. See you next time.